if we want to repeat the command move 10 steps forever, we drag the move 10 steps block into a forever loop, and that does it. And we can also put multiple blocks inside one forever loop, and that will make those blocks execute in order, one after the other. All right. And finally, we learned one more block in the control tab, the orange circle, which is the wait block, which tells the sprite to wait for a certain number of seconds. And in the looks tab, we learned to use the built-in costumes of the sprites to change the sprite's look. So that's the next costume block. So moving on to what we did last week. So last week, we began making our first video game on Scratch. So if you remember the animation of the finished project that we looked at last week, it looks like this. So the user controls the player character using the arrow keys. It moves up and down, and it has this walking animation. Every time the user presses the space key, it fires a beach ball. And the objective is to hit this butterfly, which is moving up and down the right side of the stage. And every time you hit it, it says, ouch. So here's what we got to so far by the end of last class. We have this character here. He can move up and down, and he's animated, like we see here. And he can shoot the beach ball whenever he presses the space key. So we didn't add in the butterfly yet. So that part's going to be our focus for today. And in addition, let's review the new blocks that we learned last week. So as we mentioned just now, we have the when something key pressed, which works in a similar way to the when green flag clicked block. It fires off a script. It runs a script whenever a certain event happens. But in this case, the event is when the user presses a key on the keyboard. So here, in order to make the sprite move according to the player's directions, we have the when up arrow key pressed block and the when down arrow key pressed block. And those tell the sprite what to do when the user presses the up arrow key or the down arrow key. And what does it do? Well, it changes the character's Y position by either 10 or -10, and it switches the costume, so we have that animation. And if you remember the XY system that we discussed last week, the center of the stage is represented by X equals 0 and Y equals 0. If we move right of the center on the right side of the stage, then the number after X is positive. It's greater than 0. If the position we're looking at is on the left side of the stage, which is left of the center, then the X value is negative. And if it's above the center, if it's on the upper part of the stage, the Y value is positive. And if it's on the lower part of the stage, the Y value is negative. So when we tell the sprite to change Y by 10 or -10, we're telling it to move 10 steps up or 10 steps down. And does anyone remember why we can't use the move 10 steps block in this case? Well, it's because the character is facing right. So if we wanted to move 10 steps, it will only move right or left. And as I'd shown you last week, no matter what number we have in here, it will only make the sprite move in the left-right direction, not up or down. So in order to make the sprite move in a direction that it's not currently facing, we have to use the change X and Y blocks. That's it for our first sprite. If you remember how we added the two sprites last week, first when we created a blank project, we added a sprite that looked like this with the cat, but we had to delete the cat because it was not what we wanted in this project. And we added two other sprites, the player character and the beach ball. So do you remember how we added those sprites? Well, we did it using the Sprites panel, the Sprites area at the bottom right corner of the screen. So here you see a list of all the sprites, and when you click on each one, you see details about the sprite, such as its name, its position, whether it's shown or hidden, its size as a percentage of its actual size, and its direction, which direction it's facing. You can switch between the code for the two sprites just by clicking on them in the sprite area. And there is also a button at the lower right corner of the sprites area that lets us choose a sprite or paint a sprite or upload one, but we haven't looked at those yet. So we only saw the choose a sprite window, which looks like this. So it gives us this selection of sprites that Scratch has built in. And when we find the sprite that we want to add to our project, we just click on it. And of course, hovering your mouse on a sprite will allow you to preview the costumes of the sprite. It has different costumes. So moving on to our second sprite, the beach ball. So this sprite, if you remember from last week, is ordinarily hidden. It only appears after the user presses the space button and before it hits the wall. So we did this by asking the wall to hide every time the green flag is clicked, and every time the space key is pressed, it will go to the character, and it will move right until it hits the wall. And after it hits the wall, it will hide again. So that's pretty much everything. And note a couple of things about this project. First, uh, notice that we didn't have to press the green flag button in order to uh, make the simulation work so far. This is because all of our scripts have been triggered by keyboard events so far. So except for this one, all the other scripts start with a when key pressed block, which means that they're going to start whenever a user presses the key, even if the green flag button is not pressed. However, uh, if, for example, this script is being run, then if the user presses the stop button, it will still cause these scripts to stop. So far, the green flag button does nothing except hide the beach ball. All the other keyboard events work by themselves, and the stop button stops everything. And also notice one thing. If we try to press the spacebar when the ball is currently flying, then nothing happens. It will only work when the ball has hit the wall and it has disappeared. So here's why. When we press the space key, and as long as the ball is moving, we're going to see this script highlighted. It means that this script is currently running. And why is it running for such a long time? It's because we have this repeat until block, which tells it to repeat these instructions as long as it isn't touching the edge. So this shows us that when the script is already running and the same event that starts the script occurs again, then the script won't do anything until it has finished running. So in other words, if we have a script that's running because some event had happened, then if the event happens again while the script is already running, then nothing will happen. The script will only be triggered, the script will only be started if the event happened while the script was not already running. So that's something important to remember in Scratch. All right. So we've done that. And now we're going to introduce you to a few types of blocks. So in our first week, we saw two kinds of blocks. One of the blocks look like this. As we mentioned in our first week, it has a dent at the top and a bump at the bottom. So the way these blocks are arranged, especially the way their dents and bumps are arranged so that they fit together, that determines how the blocks are run and how they fit into a script. So if we have these two blocks snapped together, then this block will run first, and then after it is done running, it will check if it's connected to any other block under it, and if there is, it's going to run the block below it as well. So blocks like this that have a dent at the top and a bump at the bottom are called statements. So they tell the sprite to do something specific. I'm just going to make a note here. Just a second. So then at the top, bump at bottom, we have a statement. And it tells the sprite to do something specific. And we have, in our first example, most of our blocks were statements, but there were a few exceptions, like the first block in the script, the when green flag clicked block, which doesn't look much like this block. And we also have the forever block, which also has a weird shape. So we can put the when green flag clicked block and the forever block in the same category. And we can call these the control flow blocks. Control flow. So these types of blocks usually they have dents and bumps, and they control the order in which the blocks are run and when the blocks are run.
What are dents? Do you mean holes?
Yeah, so if you look at the shape of the blocks, so first let's start by looking at this block. You can see that there's a little, well, it looks sort of like a rectangle, except in two places. At the top, there's this
Little thing.
yeah, a little dip, a little hole. We're going to call that a dent. And at the bottom, there's a part that's outside the rectangle. So we call that a bump.
Oh.
Yeah. And the purpose of calling these dents and bumps is that they tell us how the blocks are run by the way they're connected. So these are responsible for the way the blocks are connected and how they form a script. Does that make sense?
Yes.
Okay, good. So back to control flow blocks. So as we mentioned, these also have a bumps and dents, but they aren't shaped regularly like this one. The way the bumps and dents are arranged in blocks like these determines the way that the statements in them are run. So these control flow blocks don't do anything on their own, but they control the way that blocks are run. So, for example, if we have a forever loop by itself or a when green flag clicked button by itself, they don't do anything. But if we add a block to it, for example, like this, then the green flag clicked block combined with this block will tell it will form a script that will run whenever the green flag is clicked. And if we do something like this, then this will tell the sprite to repeat this forever. So basically, control flow blocks don't do anything on their own, but they control how statements are run. All right. But starting with our second lesson, with our lesson last week, we saw a new type of block. So we've only seen one of these blocks so far. It's the touching edge block. Let me make this out of the way. All right. So in this script, we have a few statements and a few control flow blocks. The statements are like the show block, the go-to blocks, and so on, and they tell the sprite to do something specific, like show and go somewhere. But we also have control flow blocks, which tell the sprite to tell the script how it should execute, how it should run the statements. So those are the when space key pressed block and the repeat until block. And the repeat until block, which we learned last week, has something special that we haven't looked at before. So if we have a look at the repeat until block, it looks like this. So it looks kind of like a forever loop, which we learned in our first class, but the main difference is that this repeats these instructions until something becomes yes, until something becomes true. and then it continues. But the main thing about this block is that it has this arch-shaped hole in it. We call that a slot. This is because something is going to fit in there. And as we saw last week, blocks that can fit in there are special ones like the touching edge block. And the touching edge block is going to give us either a yes or a no. So the touching edge block for this sprite will be yes when the sprite is touching the edge, and no when the sprite isn't touching the edge. This block is in a tab we learned last week called the sensing tab. It's the first one from the top. And so let me have a note here. The touching edge block can give us a yes or a no. And so as long as this value is a no, then this will repeat. But when it becomes a yes, then this stops repeating. So the touching edge block belongs to a new kind of blocks called yes or no blocks. Or the fancy name for this kind of blocks is Boolean blocks. So they give us a yes or no, or a true or false value. True means yes, false means no.
Condition.
Yeah. So the touching something block is an example of a yes or no block. And yes or no blocks fit in yes or no slots, which are these little hexagons. So yes or no blocks aren't like control flow blocks or like statements because they don't have dense or bumps. This means that we can't do something like move 10 steps, then snap touching mouse pointer under it. It doesn't work like that. But a yes or no block fit into places where we have a hexagon slots. So they don't do anything on their own, but they tell statements or control flow blocks what to do. So for example, if we snap one of these blocks into the slots in the yes or no block, sorry, in the repeat until block, that will tell it to repeat until this is true. So that's pretty much all we have for yes or no blocks. And we're going to remember that they're shaped like a hexagon. And there's one last type of block called a number or text block that give us number or text. They're pretty similar to the yes or no blocks, and we're going to look at them this week. So that's pretty much all we have for review. Today, we're going to continue with our project last week. If you can remember, here were our goals for our project. We were.
I wasn't here last week because this is my first this year summer I was in Scratch, but I wasn't here last year because this is my first time in this term Scratch.
Yeah, so we've pretty much reviewed our project for last week. So You can make a copy of this later on. I'm going to give you the link. So, oh, and before I continue, does anyone have any other questions? All right. So, first, last week we looked a bit at what a video game is and how they are made. In case you weren't here, video games, they're basically a type of program where the user gives some input to the computer, and the computer gives them results in real time. So the user usually controls a character called the player character. That character behaves pretty consistently, pretty predictably according to the user's input. But there will be other characters in the game, or there might be an environment that the character needs to get around, and those might not be predictable. And the challenge of a successful video game is to make it fun for the player. So now that we know what a video game in general looks like, we have to look at how specifically to code a video game. We learned how to make the player control a character using the keyboard, which is using these control flow statements, the arrow key pressed blocks. We learned how to use custom sprites and add multiple sprites to our project instead of sticking with the default cats. And we learned to make different code for each sprite. So this week we're going to have a look at first reviewing these projects, reviewing these topics, and continuing to apply them by finishing our project. And also, we're going to learn how to make things happen randomly. So that will be a fun component of many video games. So first of all, if you were here last week and if you currently have a project, let's go to the Scratch website. Make sure you're signed in. And then click on the File folder button at the top right corner of the screen to open your project, and then click on the one you made last week so that we can pick up where we left off last week. But if you don't have the project, or if you weren't here, let's make a copy of our demonstration project. So the link is here. You can open it. It's in the chat. And when you're on the web page, there will be a little green button on the top right corner of your page that says Remix. You click there, and that will make a copy of the project. So all right, just a second. Okay. Does everyone have the project ready?
Yes.
All right. So I also have a copy of the project, and we're going to begin continuing it. So last week we had the two spice. This week we're going to add a third one. So if you remember how the project looks, we have the character, the ball, and the butterfly. So we're going to go to the Choose a Sprite button at the bottom right corner of the screen. That's the cat head button. And once we click there, we can type in the search bar, butterfly. We see two of them, butterfly 1 and butterfly 2. I'm going to use butterfly 2 for the example. Look, and it's there.
Do we have to use the butterflies?
Well, if you have a better target character that you have, then feel free to use that.
I think this is like like this summer's scratch.
Yeah.
So I was there, so I basically already did this project that time.
Yeah. If this is a bit repetitive, then well, apologies. But since most of the people in this class weren't here when we did this last time, we're going to still go on with this project. So this might be a bit of a review for you. Hopefully there's something in the classes that we haven't covered on last session. But,
Yeah.
all right. So once we have the free sprite with the butterfly that we've just added, we're going to first tell it how to move. If we have a look at our demonstration, the butterfly rotates as it falls down from the top of the stage to the bottom. So we're going to use the change y by block again because we want it to move down regardless of which direction it's currently pointing in. We're going to use the turn 15 degrees block because we want it to rotate. We're probably going to use the repeat until block again because we want it to repeat falling down and turning in a certain direction until it hits the edge. And after that, we don't want it to repeat again. And we're going to need the when green flag click block to start the script. And a go to block, which is in the motion tab. Go to X something, Y something, it's that one. And that tells us to go to a particular point on the stage, as we saw in our first week. So how do we combine these? Each time the green flag is clicked, we want it to first go to the top of the stage, and then we want it to repeat until it's hitting the edge, turning to the right and changing Y by 10, or minus 10, which means it's moving down. And to make so that we know when it's touching the edge so that we can stop it when it's out of bounds, we're going to use the touching yes or no block from the sensing tab again. And it's still going to be touching edge And we're still going to put it in the repeat until block. And then we want to put the turn 15 degrees and change y by blocks in the repeat until block, because those are the instructions we wanted to repeat. And we don't want it to repeat moving to the top. So we're going to put it outside the repeat block. And finally, we're going to snap this onto the when green flag flipped block. So now we have a script. So if we press the green flag button, then we can run that script. And here's the problem. We see that it isn't flapping its wings, and once it goes to the bottom, it doesn't go up again like we saw here. So
I think I know why.
Yeah. Can you tell us why?
Because you only wrote it to change y to go down. You didn't say it to get back up.
Yeah. So we can add another go-to block at the bottom, and actually let's see if this works. So we're going to make this the top again, and this too. And we're going to try that. Well, it doesn't fall down a second time. If we wanted to fall down a second time, we would have to copy this again, and so on. But there's a simpler way. We can just put a forever loop, a forever block, around this whole thing, and that will tell it to repeat this whole set of instructions over and over again. So as soon as the green flag is clicked, we enter this, and that tells the sprite to go to the top, then repeats these until it's touching the bottom edge. And then once it's done that, it goes back to the forever loop, which calls this again, which tells us to go back to the top. And then this repeats again, so it falls down. Then the forever loop executes a third time, and so on. So here we basically have one repeat loop in another repeat loop. So that might look like a complicated concept at first, but if you follow the way the bumps and the dents are arranged, you can figure out how the blocks, you can figure out in what order the blocks are running. So if we try running that, that looks better. And if we wanted to flap its wings, we simply add a next costume block from the Lux tab and put it here in the repeat until loop, which tells it to change the costume every time it's flaps, every time it moves down 10 steps. Oh, and it's getting stuck at the top. We can make this a bit lower, like 105. That should work. Nope. 100. Yeah, and that will work. And its wings are beating a bit too quickly. So we're going to go to the Control tab and add a wait block. It's just to 0.1 seconds. Well, that's too slow. 0.05. That's better. So now our butterfly moves like it's supposed to move, we're going to program the ball and the butterfly so that they can, the butterfly can respond when the ball hits it. Right now, the ball doesn't do anything to the butterfly. We're going to look at how to make that happen. But before that, Dylan, do you have a question?
I just want to say last year's code was a bit different.
Yeah, it was a bit different, but both work pretty much in the same way. So we can have two codes that look different, but they do pretty much the same thing. And that's pretty much what happens here. So we want the ball to hit the button. First, we want the butterfly to know when it's hitting the ball. And when it does that, we want it to say ouch. But we also want the ball to know when it's hitting the butterfly. And when it does that, we want it to disappear. So we're going to start with a butterfly. In fact, we're going to create a new script. So this one is responsible for falling down. But we don't want the code for it to fall down and the code for it to say ouch to interfere with each other. So as you see here, the butterfly keeps falling down even after the ball hits it. It only says ouch. So we're going to make a new script. So how this works is we're going to still use a forever loop because we wanted to keep detecting whether it's being hit by the ball, because there isn't a trigger block that tells the sprite to there isn't a control flow block that tells the sprite to run a script only when it detects that it hits a sprite. So instead, we have to use the forever loop, and we have to make the sprite a check all the time whether it's hitting the beach ball, and when it is, we're going to make it say ouch. So we're going to need when green flag clicked block again. We're going to have the forever loop. We're going to have the touching block from the sensing tab again, the one that's a yes no block. But instead of touching the edge, we're going to make it sense whether it's touching the beach ball. And we also need the block that makes it say ouch, which is a new block. It's in the looks tab because it changes how the sprite looks by adding a speech bubble, like the one you often see on comic books, to the stage. So we find that in the looks tab, the purple circle, there's a block that says say hello for 2 seconds. So that basically means say whatever this message is, then wait 2 seconds, then hide that message from the stage. This is the one we're looking for. And instead of hello, we're going to make it ouch, say ouch for 1 second. Dylan, do you have a question?
What about the block that says say hello?
So the say hello blocks, good question. The say hello blocks is that tells the sprite to say this message, and then it will show this message, and then we'll forget about it. So this message will appear on the stage, and it won't disappear ever again. but we don't want that to happen. We want the ouch message to disappear after a few seconds or after 1 second. So the say something for something seconds is the one we want.
Oh, I see.
So here we can connect the forever block to the green flag block. Now we have a problem. We want the butterfly to say ouch when it's hitting the beach ball, but only when it's hitting the beach ball. How do we do that? Ryan?
I think we might have to go to control and do like if then block and then put the touching ball in, and then we could say hello in the if then.
Yeah, that's exactly right. So we have to learn a new control flow block that we haven't seen before. It's the if then block. So we have this in the orange control circle. If you have a look at this, it looks pretty similar to the repeat until block, but they do completely different things. The if then block, it also has a yes or no slot, a Boolean slot. But what it does is it runs whatever blocks are put here only if the yes or no block turns out to be true. So it will only run this if whatever block we put here has a yes answer, but not if it has a no answer. If it has a no answer, then it skips these blocks entirely, and it goes directly out here. Whereas if whatever block we put here is true, then it will run this, and then it will continue with whatever code is behind it. We also have the if then else block, which does something both if this is yes and if this is no. So these two blocks are pretty similar, but this block only does these things if a yes or no block is true, and this block, the if then else block, does two different things, whether it's true or false. But here we only want it, the only thing we want the butterfly to do is to say out, and the only condition is if it's touching the beach ball. So we don't need an else statement attached to the if then block. We're going to use the plain if then statement. And we can, if you already have this, you can easily get this by dragging the touching beach ball block into the hexagon slot, the yes or no slot in the block, and also dragging the say out block into here. And finally, you should put this whole statement into the middle of the forever loop that's empty right now. So we have this. And that should make the butterfly. Yeah. That should make the butterfly respond whenever it's touching the ball. So here's what we did so far. And finally, we're going to add a tiny bit to our beach ball script so that it will detect when it's touching the butterfly, and then it will stop rotating as if it had hit the wall. Andy Lynn, do you have a question?
I think you can make the beach ball when you shoot it go a bit faster.
Yeah, that's right. So although we don't have a weight block here, if we wanted to go faster, we just change how much the x value changes every time the repeat until block is called. So that makes it go faster. All right. So how do we make it sense when it's touching the butterfly? Well, we can use the touching something block in the sensing tab again. And instead of mouse pointer or edge, we want to change it to butterfly 2, which is our spice here. So essentially, now what we want to do is we want the ball to keep flying in the right direction as long as it isn't touching the edge and it isn't touching the butterfly. So what we want to do is this. Repeat as long as not touching edge and not touching butterfly. Which is the same thing as saying repeat until touching edge or touching butterfly. So in Scratch, we only have a repeat until block. We don't have a repeat as long as block. So we're going to use this one. So we want the beach ball to repeat moving to the right until either it's touching the edge or it's touching the butterfly. And if either touching edge is a yes or touching butterfly is a yes, then we want to stop repeating and hide. So how do we do that? Well, we're going to learn another tab, and there's another yes or no block in that tab for it. It's called the operators tab. This is the green circle at the left side of the screen. And about here, you can see the something or something block. That's what we want to use. So we want it to repeat as long as, well, we want it to repeat until either it's touching the edge or it's touching the butterfly. So the or block, as you can see, has an overall hexagon shape, meaning it's a yes or no block. It gives us either yes or no, but it also has 2 yes or no slots. So basically what it does is it takes 2 yes or no values and it looks like both of them. If the first one is true, or if the second one is true, then the or block becomes true. And the or block is also true if both the first block and the second block are true. But the or block will become false if both of them are false, if both of them are no. So for example, if we have an or block that looks like, if it's going to type it here, 1 equals 1, or 1 equals 2, then this will give us yes. If we have 1 equals 1, or 2 equals 2, because 1 does equal 1 and 2 does equal 2, then we're also going to have yes, because both of these values are yes. But if we have something like 1 equals 2 or 1 equals 3, then that will give us a no. Just because 1 doesn't equal 2 and 1 doesn't equal 3. So we have no or no, which gives us no. Yellen, do you have a question?
Why is the first one yes when this one is a no?
Well, in the first one, the first yes or no value, 1 equals 1. Well, that's a yes because 1 does equal to 1. And the second one is a no because 1 doesn't equal to 2. So what the OR block does is it checks whether one or both of these are a yes. And as long as one of them, at least one of them is a yes, then the OR block will give us a yes. Because in our example, the 1 equals 1 block is a yes. And that's pretty much enough to tell the OR block that out of these two blocks, out of these two statements, at least one is a yes. So that will give us a yes. But for the third one, neither of these are true. So there are no true values in the expression. So that will give us a no because, well, none of these are true. So,
Oh,
yeah. I know this is a bit complicated, but we're going to soon see how to use them. So basically, after we've seen this, we can just drag these two blocks, the touching edge block or touching butterfly block, oops, into our OR block and drag our OR block into the repeat until block. So what this does is every time it repeats this, every time before it repeats these, it checks both whether it's touching the edge and whether it's touching the butterfly. And as long as one of these is true, as long as either it's touching the edge or it's touching the butterfly, or maybe both, then it will stop repeating. But if neither of these are true, if the ball isn't touching edge and the ball isn't touching the butterfly, then the OR block will give us a no answer. And that will cause the statement to keep repeating. Does that make sense? All right.
yes.
So if we run the project, if the ball hits the butterfly, then it will stop. If it doesn't hit the butterfly, it will continue until it hits the wall. And the butterfly, as we saw earlier, will respond to the ball hitting it. So that's pretty much our finished project for this week. Does anyone have any questions about it? All right, so we finished this project. Next week, we're going to look at something new. And I'm going to post the link to this project in the chat. So if you want to review it after class, this will always be available at the second link that I've posted in the chat. So see you next week.